Hi students, welcome back to Physics for All YouTube channel. Today's session I am going to explain you about matter waves, which is also called as de Broglie dual nature of matter wave. So before going to the de Broglie dual nature of matter wave, first of all we have to understand about what are the properties of a particle. Generally we know that a particle is described by mass m. When the particle is moving from one place to another place, that particle has to gain velocity. Because of mass and velocity of the particle, that particle has to gain momentum. Then due to the change in velocity of the particle, that particle has to gain acceleration as well as the energy. Now coming to the properties of a wave, a wave can be characterized by its wavelength, its frequency, amplitude, time period and phase. Now we can compare both the properties of a particle and properties of a wave. There is no similarities between the particle property as well as the wave property. But from the experiments like photoelectric effect and Compton effect. So what is the meaning of photoelectric effect? When photons of sufficient energy incident on the photometals like lithium, sodium, potassium, rubidium and cesium, these incident photons are interacting with the electrons of the outermost orbit of the respective photometal atoms. This interaction will give emission of electrons from the respective atom. Because of emission of electrons from the respective atom, these electrons will move in a particular direction, which can cause photocurrent. This phenomena is known as photoelectric effect. Now in this photoelectric effect, photons are interacting with the atoms of photometals and they are behaving like a particles. Now coming to the other experiment known as X-ray diffraction. Now in this X-ray diffraction experiment, now when X-rays are traveling in the medium, then these X-rays are interacting with the substance, then these X-rays obeys the principle of diffraction. Already we know that diffraction is a property of light. According to the X-ray diffraction effect, here electrons or X-rays are traveling in the form of waves. Now this photoelectric effect concludes that photons are having particle nature. Now this X-ray diffraction effect concludes that electrons or X-rays are having wave nature. Both the photoelectric effect and X-ray diffraction, both the experiments are successful and we are using right now. Therefore, these two experiments concludes that depending on the circumstances, a wave can show particle property and particle can show wave property. This phenomena is known as dual nature of matter wave, which is proposed by the de Broglie. This is a fundamental concept of quantum mechanics. Okay. Now after this dual nature of matter wave, next we have to discuss about what are the properties of de Broglie waves or what are the properties of matter wave. Now already we know from the equation lambda is equal to h divided by mv, the following points can be concluded. In the equation lambda is equal to h by mv, we know that h is a Planck's constant, m is the mass of the particle moving like a wave according to the de Broglie's theory, and v is the velocity of the particle moving like a wave according to the de Broglie dual nature of matter wave. Now from this equation lambda is equal to h divided by mv, h and velocity are constants. Then what you can conclude here, lambda is directly and lambda is proportional to 1 divided by m. It indicates that if mass of the particle is very low, then wavelength is very high, because these two are inversely proportional. Like this we have some properties of the de Broglie waves. The very first property is, if lighter the particle, then higher the wavelength of the particle, because these two are inversely proportional to each other. Now coming to the second property, if velocity of the particle is low, then the particle has longer wavelength coming to the third property, these matter waves are produced when the particles are in motion, either charged or uncharged. These matter waves are not the electromagnetic wave. These matter waves are the pilot waves which are guiding the particle. Now, last property of the matter wave that concludes that matter waves travel faster than the velocity of light. This is about properties of de Broglie waves or matter waves. Now, coming to this is a very important question. Generally, this question is frequently asking in the 2 marks or short answers category. Now, this is differences between the matter wave and electromagnetic wave. Very first property is the waves associated with a moving particle are called as matter wave. Now, coming to the electromagnetic wave, the waves in which electric field and magnetic field are perpendicular to each other. This is called as electromagnetic wave nature. Coming to the second difference, matter waves are produced by the motion of particles, whether they are charged or uncharged. That means when the particles are charged or uncharged, then from the charged bodies we will observe the production of matter wave. Now, coming to the electromagnetic wave, they can be the charged particle can produce only electromagnetic waves. Coming to third one, matter waves can travel with a velocity greater than the velocity of light, that is equal to 3 into 10 power 8 meter per second. Matter waves are having velocity more than the velocity of light. Coming to the electromagnetic wave velocity, their velocity is equal to the velocity of light, that is 3 into 10 power 8 meter per second. Then coming to the matter wave properties, velocity is not constant, here velocity is constant. Wavelength of the particle depending on the mass as well as the velocity. Now, wavelength of the particle depending on the lambda is equal to hc by E. These are the differences between the matter wave and the electromagnetic wave. These are